Alright, so we're going to start chapter 4 today. Today we're going to go through 4A and 4B because 4A is only really short. With chapter 4, it's sort of a bit of a funny sort of chapter, the way the book's set out. So with 4C and 4D, I'm going to split the exercises up a little bit and we're sort of going to mix them around because it's sort of, there's things we have to know which the textbook doesn't, like it teaches, but then there's no exercises on it. So I'm going to split it up. We're going to go through those parts in separate parts and I'll give you some different exercises from different textbooks to go with those. So you've got practice on those sort of questions. So it'll take us a little bit more than, because there's only 4 parts to chapter 4, so it'll take us more than 4 lessons to get through it, just so we can break it up and go through it in depth so we can totally understand it. So that's where we're up to with chapter 4. So chapter 4, we are looking at regression lines, and this is probably one of the most important parts of the whole core, because once we start to learn about regression, we will find that pretty much probably about 70% of our questions will have something to do with the regression line. So it's really important that we've got a really good understanding of a regression line, how to find it, how to interpret it, and how to use it. Alright, so if you don't understand the regression line, please make sure you ask some questions about it so that you get a good understanding. Because it's pretty much the basis of the rest of the unit. Oh, did you miss one? That's all right. Okay, so regression. So what a regression line is pretty much a line of best fit. So if we have a scatter plot, we're pretty much trying to fit a line that goes through not the most points, but a line that represents the data. So it's got the same trend as the data, and we've pretty much got about the same amount of points on both sides of the line. So if I was doing this by hand, we could see that I could probably draw one there, or I might sort of draw one that way, or I could draw one maybe that way. So we could see if we're drawing it by hand, there's a few ways we could draw it, and we'd all end up with different answers because all of these are 3 different lines. So what we're going to be looking at mostly is what we're going to call the least squares regression line. And we're going to do it on the calculator, and it's the calculator calculates pretty much the line of best fit using a mathematical method. So the line we're using is the least squares regression line. It's going to give us a really accurate answer, and we'll all end up with the same answer. So that's pretty much the gist of the least squares regression line. So we'll go through this. Once we establish an association between 2 variables, we can fit a line of best fit. To fit the scatter plot. And once we've got that line of best fit, we then find an equation for the data. And this equation represents our data. Yeah, go for it. We then use this equation to help understand the relationship between the 2 variables and to make predictions based on the linear model. But as we can see, it's impossible to fit a straight line to all of these dots, because if we did it, the line wouldn't be straight. So we calculate the line of best fit. Oh, not the line of best fit, sorry, I've already got the line of fit. We calculate the straight line, sorry. The straight line to find the line of best fit. Which we are calling the least squares regression line. So we're just fitting a straight line to our data. We calculate it and it's called the least squares regression line. So the way it's calculated, if we have a scatter plot, I'm going to see if I stand there, sorry. If we have a scatter plot, what am I talking about? Oh, okay, so if we have a scatter plot and we've got a least squares regression line to it, all of these data points, not all of them are on the line, so what we have is the vertical distance of our data points to the line is called a residual. So that's what these things are called. They're called residuals. And the way we calculate the least squares regression line, it is found by minimizing.
What's it called? Residual.
Residual.
Oh, residual.
Minimizing the sum of the squares of the residuals. So you won't have to do this, but I'll explain how it works. So pretty much there's a distance between each data point and the line. And that distance is squared. All right, now if a residual is below the line, it's going to have a negative residual value because it's below the line. If it's above the line, it's going to have a positive value because it's above the line. All right, so the way the line works out where it actually fits in that data is these values of the residuals, they're all squared and added together. And then what the calculator does, it adjusts that line until it finds the point when they're all added together, the sum of the residuals, the squares of the residuals, is as small as possible. So as close to zero as it can get. You won't have to calculate those squares individually or anything like that. I'm just explaining how it works. Because you may get a question about, especially in your multiple choice exam, what is the correct calculation for a least squares regression line. Just as long as you know that definition, make sure you've got it somewhere in your notebook, you'll be okay. You won't have to do it by hand like that at all. Definitely not. All right, so don't get too confused about that. I'm just explaining how we do it. So then the residual, which we're just talking about here, these sort of green liney things, is the vertical distance of an actual data point to the least squares regression line. Any questions so far? No, I've just said a lot of words. So in a nutshell, we've got two new definitions. We've got a residual, which is the vertical distance from a data point to the regression line. And the other definition we have is the least squares regression line, which is line of best fit, which is calculated by minimising the sum of the squares of the residuals. That's pretty much what we've done so far, we've talked about. Can I move down? Yep. Nope, maybe.
Yep.
Okay. That's alright. Oh, not that far. Okay, so when we are calculating, or when we are using the least squares regression lines, there's three things that we are assuming about our data. The first thing we are assuming is that our data is linear. If we have non-linear data, so if we have data that ends in a curve or something, we will still get a least squares regression line. But our least squares regression line is always a straight line, so it won't be a good representation of the data. Because our line would go something like that, and it's really not showing the trend of the data. So our data has to be linear for us to fit a relevant least squares regression line to it. Our data has to be numerical. And we don't want to have too many outliers. Because if we have an outlier, let's say I had a data point right down here, what that would do then, that would make the line adjust to this data point down here. And then all of a sudden, this line really isn't fitting the trend of the majority of the data points. So if we've got a really clear outlier, a least squares regression line isn't going to fit it that well. Alright, don't worry about this bit because it's exactly the same as what we wrote up top, and I don't know why I've got it down there as well. It's actually exactly the same word for word, so don't even worry about it. So these two graphs, what the calculation means is we've got just a bit of a diagram of a scatter plot. So that's our least squares regression line, and then residual is the distance from the line. Anyone got any questions about this?